So the title of this lesson is called Solving Equations. And this solving equations actually is far beyond the topic of the day. We're going to see this solving equation in trigonometry. We're going to figure this out or use this when we do linear functions, when we do quadratic functions, when we do geometry. So this is a very, very important topic, okay? Solving equations. Now, before we do that, the question is, what is an equation? Yeah? Equation is that when you have two expressions on each side of the equation, and then there's an equal in the middle. So you have the left side expression and an equal to the right side expression. Okay? So in an equation, it's going to be a balance. The left side should always equal or balance with the left side. Done all right? Mm-hmm. That was fast. Okay? So in an equation, there's a balance on the left and on the right. Now, because we're trying to solve for something, what we're going to do is we're going to look for a number that will make an equation true. Okay? So we have to look for a value for the variable that will make the equation true. So here, now to do that, we gotta do what we just talked about earlier. Okay, let's see. I'll give you a specific example. I'll start with that. So here's a specific example. X plus 3 is equal to 15. So we have an expression on the left, which is the x plus 3, and on the right side you have a 15. Okay? So we're looking for a number to replace the x so that the left side balances with the right side. Now, I know this is easy. You probably have a number in your mind. Okay? You already have a number in your mind. Anybody want to say what number that is? 12. Okay. Well, how did you know 12? Well, because you know math, right? Because you know math already. You know 12 works because if you replace the x with 12, you know it's 12 plus 3 will give you 15, right? But it's not, okay? Now I'm going to ask you a different one. Okay, so the second equation there is a very similar concept. I just changed the numbers. Now, that one is a little bit challenging. Like, how do you do that, right? Okay, maybe you have a strategy already. I'm not sure. Okay, so, okay, I'll up it up a bit here. Okay? How do you do that? So solving for x. Now, we're going to start with something easy, right? Something easy, but I'm interested in the answer, certainly. Of course, we are all interested in the right answer, but I think what we need to do today is look for strategy on how we can actually solve it. But we did try that when we did the demonstration earlier. So, what do we need to do is we need to do the opposite operation. What's an opposite operation? Opposite operation. So, to solve a variable, okay, in a one-step equation, we have to do the opposite operation. And just like Jonathan earlier, you know, I told him to step forward 3 to get back to x. He needs to do the opposite, which is step back 3. And then when I ask him to go to the left 5 and to go back to the x, what did he do? He had to do the opposite of left 5, which is right 5. Opposite operation. So, we know some opposite operation. In math, it's, you know, there's always an opposite operation. Okay? So, if you know how to do this, you can solve any equation. And you're going to be probably in science, and some of you are, right? Maybe some of you are in science. And you do solve for equation quite a bit. So, when you see adding, what's the opposite of adding? You know this already. Subtract. When you see a multiply, when you see a subtraction, when you see a divide, you multiply. When you see a square root would be, this is a square root, square. And when you have a cube root, what do you need to do? Cube it. Okay? So there's going to be an opposite operation to solve for a variable. Okay, so we do the opposite. So that's the first key point, is to do the opposite. Here's the other key point. Sorry. Another thing that we have to think about is the word equation. The left side has to balance the right side, yes? That's what it means by being equal, right? If the left and the right are not the same, are not going to be balanced, they're not equal. So we want to make sure that they're equal on the left and on the right. So, I think somebody already said it earlier. Somebody said, and I'm pretty sure you heard it from your other teacher, is that what you do on the other side, you got to do it on what you do on one side, you got to do it on the other side. Have you heard of that term before in solving equation? Why is that? Why is that? So it would continue to balance, right? If you add 3 here, well, you got to add 3 in this side too. Because if you add 3 here and not here, that's not going to balance. If you take away 3 from here and you don't take away 3 on the right side, that's not going to be balanced. So another key point is that also what we do on one side of equation we must do the same on the other side. Okay? And I like the equation. And I tell this to my students. I like the equation because the word equation is being fair. What you do on one side, you gotta do it on the other side. Right? You gotta be equal, you gotta be fair. So, having those two concepts, we can actually solve for the x. And solving for x means, okay, x means the variable means to find out a value that will make the equation true. Okay, solving for x is finding a value for x, finding the value for the variable, so when we figure it out, when we put the x, the value in replacement for x, the equation holds true. That means the left side is really equal to the right side. That means the left side is really equal to the right side. Okay, good? So, here we go. So that's the first part there. Now I think we're ready to do the examples, because now we have a background story about this. So let's take a look at example 1. Okay, so I can see people are still copying, so I'll wait a little bit. So keep going. Okay, ready? Now, some of these are super easy. Like I said, solving equations, the ones in here, the examples, the practice are super easy. But we can step it up a little bit, get a change in number, and as you can see earlier, we can start off with easy, but it could get challenging, right? It can easily get challenging, so we can't just rely on, you know, what we know, and this is easy for us. We need a strategy, okay? Can I move it? Okay, I'll put it back if you're not sure, if you're not done. And we're gonna start with a baby step, and that's what I like about this, is the baby step and one-step equation. So example number 1, it says there, x plus 2 equals 9. All of us, I'm sure, know what the answer is. I don't care if you know the answer, but what we're trying to do here is that, sorry, I do care about the right answer. Backtrack. I do care about the right answer, but I want us to also know the way to do that. So when it gets complex, you have an idea on what to do. You don't say, oh, I don't know. Okay, so what are the expression? On the left, what do you see on the left side of the equation? left? Okay, sorry. The other left. X plus 2. X plus 2. On the right side is what? 9. Okay. Good. Now, what's happening with the x? X got added by 2. X got added by 2. So what are we going to do? We're going to solve it by doing the opposite. You see, I see adding of 2. To do the opposite would be? Subtracting of 2. So, please, I know you know the answer, but get into the habit of this. So subtract 2. Okay. Now if I subtract 2 on one side, I gotta be fair and do subtract 2 on the other side. That's the other thing. So subtract 2. So I'm subtracting 2 on the left and I'm subtracting 2 on the right. Okay. What happens is adding 2 and subtracting 2 cancel each other out. What's left over? What's left on the left? What remains on the left? X, yes. Equals what remains on the right? 9 minus 2 is 7. Is 7 the answer? Yeah, well, before we even did that, I know you know it's 7. But it's not the final answer that we're interested in. We're also interested in the process. So the answer is 7. Okay, how do we verify if our solution is correct? Okay, so we know the left side has to equal to the right side. What we're going to do is we're going to substitute 2 to replace the x. So you go x plus 2 here, and then the right side is 9. So I'm going to replace the x by 7, add 2. The left side is 9. The right side is 9. 9 is equal to 9. Is 9 equal to 9? Yeah. Yes? Now, let's say I made a mistake and I got add 2. I'm going to try to make a mistake here, okay? Because I want to prove a point here. Let's say I made a mistake and I say, oh, I'm going to add 2, I'm going to add 2. And this is my answer. Is that correct? Why not? Because if you go 11 plus 2 is 13, well, 13 is not equal to 9, right? So, okay. So it has to be the left side is equal to the right side. Okay, let's take a look at example number 2. We're trying to figure out what the value for x is. What do you see? I see subtracting 12. So what's the opposite of subtracting 12? Adding 12. So adding 12, adding 12. Okay? Adding 12, that cancels out. Okay? What remains, there's gonna, when you do this, you always have the left side, you always have the equal sign, and you always have the right side. Okay? So subtracting 12, the opposite of adding 12, remains is x equals, that's gonna be 43. Okay? Verify solution. Left side, right side. X minus 12 is on the left side. On the right side is 31. I'm going to replace the x with 43. And that's equal to 31 equals to 31. So 31 equals to 31. And that's correct. Okay? Good? So far so good? Go to the flip side. Too fast? Sorry, it's too fast. Yeah.
I want to see how we studied.
Huh?
We were doing practice, so is that okay if I put?
Oh, that's how I learned it. Do you know why it changed? Okay. Summer Howard said,
People equal meters.
that's how I learned it in my time. My time, this is what it is. I'm pretty sure Abdul could say the same thing. Okay, Summer Howard is saying this. This is what I'm doing. This is a wrong answer. I'm showing you the wrong answer. This is what Merhawat is saying. This is probably how she learned it in her school. Her teacher said, you take this, bring it to the other side, and it magically becomes 12. This is not supposed to be magic. Okay? What happened there? It's not, that's how I was taught too. And I didn't understand why. And my teacher didn't explain why. And I'm trying to explain it to you so you understand why. So what happened here is your teacher did this without telling you. Okay, you got conned. You can't just say that. You can't. Your teacher is correct, but they didn't explain why. Okay? Your teacher says, this is a minus 12. I'm going to do the opposite, which is
12.
add 12. Okay, it's not magic. That's how I learned it. My teacher said when the number goes over the equal sign, it changes to its opposite. There's a reason. Because you're trying to isolate the x and you're doing the opposite of that. Now you know why. Good. Now we can do the other side. Yeah, that's a good one. You know, the very question that you should ask as a student, as a learner in math, and as a learner of anything, is to ask the question why. Because you've already accepted that if I move this over there, and then the teacher says, I said so. Question is why? Why is that? So, there you go. Now you're like, oh, now I see it. Okay, here, what's happening with the x? 54 got added with the x. What are you going to do? Subtract by 54. Subtract 54, because we're trying to find out the x. So subtract 54. If I do it on one side, I got to do it on the other side. So that cancels a 54. And you're left with x equals to 75 minus 54 is 21. Okay, I'm not going to verify. Leave it like that. Okay? Example 4. What are you going to do here? Sorry. Bring it down. Okay. Example 4. 122 plus x equals to 99. What are you going to do to solve for x?
Add a negative number?
Yeah, okay, yeah. You can say, oh, it's a positive 122. Opposite of that is a negative. Or you can say a minus 122. Okay, so I can go minus 122. What I do on the other one side, I got to do it on the other side. What remains is x equals to, okay, negative 31. Okay. Is negative 31 make sense? Does that make sense? 122, and if I add a negative 31, I'm going to get a 91. Yeah, that makes sense. Because if you add a negative, some positives would get canceled. So it's now net. It's now 91. Okay, next one. Next part. 567 equals to 24 plus x. How do you solve for x? By?
24.
Okay, what are we going to subtract by?
24.
24. Subtract by 24. Subtract by 24. Okay. So you're always focusing on where the x is, right? You're doing the opposite of what happened to x. And then you do it on the other side. So what remains is 543, thank you, and remains is x. Not bad, right?
Do we need to show like that work? Because we did it differently. Yeah, that's fine. We have the same one.
Okay. Oh, how did you do your weight?
We just,
Show.
it's pretty much the same thing. We just don't subtract 24 from 24.
Can I see? Can I show to everybody? Is it okay if I show to everybody? Oh. Well, okay, because we lost the x. Okay. What you're trying to do here is verify. Okay. That. Okay. Is it okay if I show it? Okay. Thank you. That's good. Are you the same?
Yeah, we did the same.
What we need to do is we need to maintain our equation. So we can't lose the x. So here's it. Thank you for showing it to everybody because we're all learning here because we wanna see how it's supposed to be done. Thank you. Appreciate that. Okay. Okay, this is example 1. The answer is, what's the answer? 7. Okay. What happened to the x? So I appreciate, no, okay? Yeah. So here, it's more like, I think I know the answer. Okay. So then this looks like a checking, verifying, and then the answer is 7. Good, good. It's good. Thank you. I appreciate this. And I'm
So we can do that.
no.
Okay.
No, sorry. No, because I want to remember yesterday I said like when you're doing the fraction, you do it step by step by step. You copy line by line. The line on the top should equal to the line in the bottom, right? So this one here, the line on the top doesn't really equal to the next line. Okay, so let's go back. So we have to maintain where the x is. We're solving for x. So, yeah. Get into the habit because this might make sense to you. This might make sense to some people. Okay, I'm talking generally. This might make sense to us, but this is a one-step equation. This is only one-step equation. There could be multiple step equations. So, doing it like this works on a one-step equation, but we're going to have a hard time later on when we have a multi-step equation. Okay? So thank you. I'm going to get you to copy down the right way, okay?
So we can look at the same thing we did here. Select the 12 to the second term and we change the sign. That can be it's okay.
Oh, you mean this one?
That one is,
Bring this over here.
yeah. And do it.
This one is okay. But you understand why it magically became positive, right?
Yeah.
So when we do that for P is okay, because we used to do like.
You're used to it. Yes, I know. I'm trying to unpack it for you. And now you know why this is true,
Yes.
right? Your teacher didn't do this,
Yeah.
but that's exactly what happened. Okay?
So we can work like this, isn't
You
it?
can still work like that. See, the equation is still,
The same.
there's still a left side, there's a right side, and there's an equation in between. Okay, good, good. Okay. I'm gonna get us to do this part in here. Please show your work, okay? We want to know the answer, yes. The right answer, yes. But also the process. Okay? So, you want to do this? You want to do this on your own?
Like same like you did in the beginning, like crossing up. Okay.
Yeah, yeah. So I'm gonna stop this video here. Please work on page 13. Follow the steps. Okay?